స్క్రీన్ షేర్
Okay,
చేశారు
sir.
కదా సార్, స్క్రీన్ షేర్ చేసినప్పుడే బ్రేక్ అయిపోయింది. సారీ సార్.
Okay, sir. I will start from the beginning. Okay. Right. So now, can you able to see the screen, sir?
Yes, sir. Yes, sir.
Oh, okay, fine. So in the previous class, we have seen with the black box testing, where we have seen all the tasks related to that particular black box testing. So where we have seen decision table based testing, and before that we have seen this BVC as well, that is bounded state table based testing we have seen, decision table testing we have seen, BVC we have seen, that is boundary value checking also we have seen. Okay, so equivalence class testing. So in that we have seen the boundary value checkings also we have seen in the previous class, and so we have also checked with the problems with BVC, and remaining things also we need to check whether we could able to go with the solution or not, that we need to check. Okay, so that is the only thing which you need to identify from the uh, previous class. And at the lateral part we have seen the need of white box testing, and then we have checked with the logic coverage criteria, where we are having each and every line has to be tested by the tester, so which is said to be as the statement coverage, logic coverage, that is decision coverage, right? So condition coverage, right? So decision or condition coverage we are checking. So multiple condition coverage also we are checking. So like that we are checking for the each and every line of the program which is being written by the developer has to be checked or tested with the help of the tester. Okay, so then we have checked with the basis path testing. Okay, so in basis path testing also we have checked with each and every aspect, that is what you mean by path testing, and how the control flow graph will be for a given graph, right? So, and what is the meaning of node, what is edge or link, and what is decision node, what is junction node, and what is mean by a region. And then we have checked with the flow graph notations for different programming constraints, right? So there we have checked again the path definition, segment, path segment, length of a path, right? So independent path. So all these things we have checked in this particular previous concepts, right? So then we have seen the cyclomatic complexity as well, right? So then we have checked with the guidelines for basis path testing, and there we have stopped our discussion in the previous class. Okay, so now just we were discussing about this particular program, that is example, right? So here the task is, so the users are going to get either the code or uh, any program has to be written by the user, and that programming part has to be tested by the users. Okay, that is whatever the program that you are going to write has to be tested by the testers. Okay, so in this case we are getting a question that is in the form of a program. So that program, here we are having it as a C program, so which is given as whether the given number is a prime number or not, that the question we need to answer, that is that C programming we need to answer with the help of these lines of code which is available for us. Okay, so here we are having some 15 lines. So starting from the main method, so we are having the code which the user has to check, that is the which the user has to test. So here it is having declaration as integer number and index. Then we are entering the number, then we are taking the value, then we are initializing the index to 2, and then we are checking while the index less than or equal to number minus 1, then we are going for number division with index. So if it is equal to 0, then we are going to say it as a not a prime number, and then we are going to break the loop, and then we are going to go for the index value increment. Then we are checking with index and number. If both are equal, then we are printing it is a prime number, and then we are ending the main method. Okay, so this is the code which is being written by a developer. So for this code, we need to test for the 4 different questions, that is which are given as A, B, C, D for the given lines of code. Okay, so here if you are going to check, the first question is draw the DD graph for the program. Then second question is calculate the cyclomatic complexity of the program using all the methods. Right. So then the third question is list all independent paths. Then fourth question is design test cases from independent paths. So whatever we are writing in the third question, so that we need to design in the fourth one. Okay. So first one, we are having it as the solution as DD graph. Okay. So data flow graph, sorry, DD graph we are having. Okay. Data definition, whatever we are defining, that we need to go for the solution. So here we are having 15 lines of code. So each and every line of code is divided into some numbers. So that is some numbering is given from 1 to 15. So based on these numberings, we are going to go for the solution. Okay. So for that also we are having some conditions, that is for drawing the DD graph, we are having some set of actions must be done. Okay. So that one are put the line numbers on the execution statements of the program as shown in the figure. That is we are having the set of statements which are numbered from 1 to 15. Those are all given from 1 to 15. Then start numbering the statements after declaring the variables. So if no variables have been declared, that is if no variables have been initialized, we have to give the numbering from the statements after declaration. So otherwise, that is if they are declared, start from the statement where the variable has been initialized. So in this case, we are having numbers from 1 to n, that is 1 to 15 we are having. So we have declared the variables, we have given the numberings, and if we are also not having any declarations, so that case also we are having the numberings. Okay. So if this one is clear, that is the program is the finding the given number is whether the given number is a prime number or not. That is the program. For that code, we are testing with our white box testing strategies. Okay. So coming to the DD graphs, the first 3 statements, whatever are there in the given lines, those are kept in a first eclipse. So which are printing the number, giving the number and taking the number, that is giving the input by the user, and index is equal to 2, that we are initializing and that we are keeping it as first set of action. Then fourth point, that is fourth line, is given as one more set of action where we are checking for the condition. Okay. So that is while index less than or equal to number minus 1. So if you are giving number as 5, so we have to check for 5 minus 1, that is 4. So index less than or equal to 4. So if index less than or equal to 4, that is 2 is less than or equal to 4, then we have to go for number divided by index, that is 4 divided by 2. So if it is equal to 0, then we have to print it as not a prime number. Okay. So if it is okay, then we have to go for prime number. Okay. So fourth one is we are checking for the condition, that is index less than or equal to number minus 1, that is while number minus 1. So we are going for the set of action which is called as 13. So which is given as 13 is if index is equal to number, that is if 2 is equal to 2, then we are going to write it as prime number. Okay. So if 2 is equal to 2, we are going to write it as prime number. So if that is not going to be happening, we are going to print it as not a prime number. That is, if index is equal to 3, or if index is equal to 5, or if index is equal to something else is there. So then depending on the condition checking, we are going to give the output. Okay, so that's why we are coming directly from fourth line of execution to 13th line of execution. So if that is not going to be there, right, so then we are going to go for end statement, that is 15th statement. So if the condition is going to be satisfied, then we are going to go for the 14th line, that is printing the number, and then 15th number. Okay, that is given as the another set of actions. Okay, so from fourth, if that is not going to be the case, if no condition is applied, so then we are going for again checking of next statement, which is called as if number divided by index is equal to 0, that value we are going to check. So that is also given as separate set of execution. So if that is going to be there, then we are going to go for 789. So what is there in 789? So here also it is there as print whether it is a prime number or not. So then break the statement and then go for the output. Okay, so that is also given over here. So from 789 also we are coming to 13, or from 4 also we are coming to 13. So that is if condition is going to be applied, that is while condition is applied. So if it is going to be satisfied, we are going to print the output depending on the statement. So if it is not available, that is if it is not there, then also we are going to go for the another set of executions. Okay, so from 789 we are coming back to the this one, that is 13 also. Okay, so from 13 we are going for 14 and 15, that is printing the number, and then we are going for the next statement, right? So if uh, that is 789 56 is okay and 789 is okay, then we are coming for these statements. So if 56 is okay, so there also we are going for the another set of equation, that is another set of statement. So if 5 and 6 that is also okay, then we are going for so another set of statements which is called as 11 and 12. So which are said to be as indexing, increment, and then closing the program, that is index value is going to be closed. Okay, so this graph we have to draw like this. Okay, so what are the steps that we are taking at a stage, and if that set of statements are going to be executed, that is if that lines are going to be executed, so where we are going to reach. So if those lines are not going to be executed, then where we are going to reach for the output, or where we are moving furtherly. So that we need to keep in the form of data. Okay, design diagram or data diagram we can say. So those aspects we need to keep. So this is given as the DD graph for the given example, that is 5.1 we can say. Okay, so here also it is given. So put the sequential statement in one node. For example, statements 1, 2, and 3 have been put inside one node. Okay, so put the edges between the nodes according to their flow of execution. So then you need to put the edges between the nodes according to their flow of execution. Okay, so put the alphabetical numbering on the nodes, that is on each node, like A, B, C, like that you have to keep. Okay, so like that we need to go for the particular solution. Okay, that is for A bit. So when moving on to the next one, that is B, so which is called as cyclomatic complexity. So for that we are having V of G is equal to E minus N plus 2 star P. So here E we are having it as 10, minus N we are having it as 8 plus 2, which is given as 4. So for the same graph we are showing the regions, that is how many regions we are having, like that we are showing. Okay, so that is VG indicates the number of predicate nodes plus 1. So 3 nodes we are having B, C, F, and plus 1 we are having it as 4, and the number of regions are, we are having 4 separate regions. Like what are the different conditions that we are checking? So first region, second region, and then third region and fourth region we are having, right? So first we are starting with the main method, then second while checking if condition we are checking, and then if again index number we are checking. So like that we are having 4 different regions for this particular given example. Okay, so while coming to the independent paths, so what are the independence paths that we are having in the sense? So since the cyclomatic complexity of the graph is 4, there will be 4 independent paths. So namely we are having A as separate path, B as separate path, F as separate path, H as separate path. So here we will be writing all the possible paths from reaching source to destination, that is from printing the prime number or not, right? So this way we can go for reaching the whether the given number is prime number or not. So otherwise we can go for A part, B part, F part, H part, and G part and H part. So that is, so A we need to go, B we need to go, right? So first path we are having is A, B, F, H. So first we can go for A part, B part, that is 1, 2, 3 statements, fourth statement, and then we can go for the F and H. Okay, from F we can go for H, that is one path we could get. Then F, G, H we can move. So F we can come, that is we can come from A to B, B to F, F to G, G to H, that is also one path. So otherwise we can go for A, B, C, E, B, F, G, H, that is one path, and A, B, C, D, F, H, that is also one more path. Okay, so as we are having 4 different independent paths as described over here in this particular cyclomatic complexity, so we are having 4 different test cases. So starting from 1, 2, 3, 4. Okay. So in the first test case, the input number is 1. In the second test case, the input number is 2. In the third test case, the input number is 4. And the fourth test case, the input number is 3. Okay. So we are going for input increment, that is index value increment, index value decrement. So as we are speaking about 1, it is not a prime number. So the output is displayed, that is no output is displayed. So if it is 2, we are going to get it as prime number. So if it is 3 also, we are going to get it as prime number. So and if it is 4, we are also going to get it as not a prime number. Okay, so simply what we are doing, we are completely checking with all these lines of code. Then we are going to go for the graph, that is if we are going to follow the same set of code, so how we are going to get the output, we are going to check. So by following what steps we are going to get the output, we are going to give it in the form of the Eclipse numbers and nodes, right? So again, these things are going to be categorized under regions, separate regions, right? So which are independent of each other or dependent of each other, either of the case. So independent regions only we are going to take, and we are going to go for the independent paths and independent uh, numberings as the question is raised with related to independence only, right? So then we are going for the independent paths, and then we are going for the test case design, that is, so by taking the values 1, 2, 3, 4, so we are going to test for the prime number or not. So like that we can test for the given code, that is lines of code. Okay. So this question is also similar to the previous question. So where the size is increased. Okay. So that is consider the following program that reads a string and checks whether the checks the type of each character, that is, so string we need to give as input. So based on the string, it is going to test and it is going to give what kind of character it is. Okay, so the input and output is here. The input is 0987. So 0 is digit, 8 is digit, 9 is digit, 7 is digit. It is giving. So it is giving the paths according to the independency, right? So it is going to give us the same string, whatever the string that we are providing as input, it is going to give us whether it is a special character or number or alphabet or what kind of thing it is associated with that program, that is with that string, it is going to give us as the output. Okay, so the next question what we are having is, we consider the following program, so which is having the switch case. So printf, whether it is a special character, special number, or what kind of things it is having in special characters, that is the program which is being given. And for that we are writing the DD graph, cyclomatic graph, independent paths, and then we are giving the inputs, and then we are checking whether it is a special character or what kind of character that is having. Okay, so that if you are checking with your examples, that easily we can go for the solutions. So then we are having the applications of path testing. So hopefully the previous one is clear. So if it is clear, then we can move on to this one, that is applications of path testing. Yes, that one is clear.
Yes, sir.
Okay. So then what we are having is the applications of path testing. So here, while coming to the applications of path testing, what we are saying is, so what are the various applications of this particular path testing we are checking. Okay. So that is, we are having various applications, okay, that are associated with this particular applications of path testing. So the path testing can be used in covering the more paths in the given problem, that is in the given graph, right? So it is used in unit testing, it is used in integration testing, it is used in maintenance testing, it is used in efforts for the propositions and all, right? So basis path testing also it is going to be used, right? So like that, it is having various applications of path testing. Okay, so then we are going to see the graph matrix or graph matrices. Okay, so a graph matrix, a data structure, is the solution which can assist in developing a tool for a automation of path tracking, that is automation of path tracing. Okay, so what is the graph matrix is going to give us is, so we are going to give the path tracing from where to where it is going to be reached with the help of this particular graph matrix. Okay, so here we are having the example, right? So here we are having 4 different nodes, so which are connected from a root node. If you are taking it as one as root node, so it is connected from 1 to 3, 1 to 2, so 2 to 4, and 3 to 4 also it is there, right? So a graph matrix is going to give like this. So what we need to write is, we need to write it, so as we are having 4 nodes, we have to write 4 by 4 matrix, that is 4 rows and 4 columns we have to write. So after writing, check where to where the connections are, that is we are having any connection from 1 to 1. So in the given figure, do we have any connection from 1 to 1? Connection from 1 to itself or 1 to 1? Do we have any connection?
Yes, sir.
So what is the name that is associated with 1 to 1? Name. So you could able to see from 1 to 3 it is C. So from 1 to 1 it is A, 1 to 2 it is B. So what is the path name that is associated with 1 to 1? So one is having self loop with itself, within itself. So the path name is it's already I have revealed the path name, but still you are unable to catch it. So the variables or the values which are associated through that line are said to be as the path names or variable names for that particular node. So 1 to 1 it is having name as A, 1 to 3 it is having C, 3 to 4 it is having E, 2 to 4 it is having D, 1 to 2 it is having B. So now tell me what is the path name for 1 to 1? Yeah, anyone is there?
B
Yes,
A,
what
sir.
is the sorry?
BA.
1 to 1 I am asking. One, not 1 to 2, 1 to 1. So you could able to find one self loop, right? One నుండి మళ్ళీ దానికే ఒక సెల్ఫ్ లూప్ లాగా ఉంది కదా, ఆరో మార్క్ సర్కిల్ లాగా పెట్టేసి దానికే ఉంది కదా. So there you have seen there you could able to see name as small letter A, right? So that is the name for 1 to 1. Okay, that is 1 to 1 name. So 1 to 1 connection you are having 1. So what is the path name for 1 to 2?
It's B.
1 to 2 it is B. Okay,
B,
1
sir.
to 4. 1 to 4.
1 to 4 E.
1 to 4.
ED, sir.
Oh,
1 to 4. Do we have any connection from 1 to 4 directly or
B.
indirectly?
Oh, sir.
So when you don't have any connection, we are not going to represent any value for 1 to 4. So in the similar case, 2 to 1, do we have any connection? 2 to 1, do we have any connection?
Oh, sir.
No, sir.
2 to 1, do we have any connection? No.
No,
2
sir.
to 3, 2 to 3,
No, sir.
2 to
No,
4,
sir.
2 to
D.
4 D, sir.
2 to 4 we are
D.
having the path name as D. Okay. 3 to
D.
4,
E, sir.
3 to 4 we are having it as E. Okay. So this can be represented in the form of graphical representation or in the tabular format, that is 4 by 4 matrix we can say. So this is going to be the solution for the given graph. I was just okay. So for the second question, that is for this one, you tell me what is the output. Okay, consider the graph and represent in the form of a graph matrix. So what is the graph matrix size? Graph matrix size. First I need graph matrix size.
4.
4.
Okay, 4. So it has to be 4 by 4 matrix.
It's
Net there. Net balance ఉంది. 1 minute ma. So what are the path names? That is, what is the matrix size you said? That is 4 by 4 matrix you said. So what are the path names that I need to know? Okay. So I want to know the path names. That is, what is the graph matrix for the given graph? So take a pen and paper, keep it as 1, 2, 3, 4, as the nodes are 1, 2, 3, 4. Again, right side 1, 2, 3, 4, you are going to write, that is row names, column names, you are going to write it as 1, 2, 3, 4. Row names also 1, 2, 3, 4. From there, check what is the path name for 1 to 1. Do we have any path name from 1 to 1?
No path name for 1 to 1, sir.
Okay, 1 to 2, do we have any path name?
1 to 2 A plus B.
1 to 2 A plus B. Why you are saying it as A plus B?
Because when we see there is a path from 1 to 2 is A, and we see a cursive path from 1 to 2 also. So just calculating the both as A plus B.
Okay, as they are in series or parallel?
I think in series only, sir.
No, it is parallel. So just like our train track, it is in parallel. That is, if you are
Okay.
going to draw the straight line, it will be A to 2. Sorry, that is 1 to 2 itself, right? 1 to 2 we
Yeah.
are having and 1 to 2 we are having.
Yeah.
So when it is in parallel, we have to go for addition. When it is in series, we have to go for multiplication. Okay. Then 1 to 3.
1, 2, 3 we can consider as C.
C. Okay, done. 1 to 4.
1 to 4 0.
We don't have it. 1 to 4, nothing is there. Only we are having two values from 1 to 2 and 1 to 3. And then we are having 3 to 4. 3 to 4. So this is the given, this is the solution for the given graph. Okay, well, so what we are doing, we are we are drawing the given graph into the format of matrix. Okay, so instead of matrix representation, we are giving it in the form of tabular format. That is, so whatever the size of the nodes are there, so we are going to give the matrix size as that nodes, those many nodes. Okay. So then next we are having connection matrix. So where if it is connected, so instead of giving names, if it is connected, we are going to give it as 1. If it is not connected, we are going to keep it as empty, that is 0. Okay. So the connection matrix for the 5.6, okay, for this one. So what is the connection matrix? Connection matrix. So if connection is there, we have to give it as 1. If connection is not there, we have to give it as 0. Okay, for the this diagram, what is the connection matrix?
Connection matrix. I think 1 is to 1 is 0. 1 is to 2 1. 1 is to 3 also 1. 1 is to 4 0. Again 2 is to 4 1. 3 is to 4 1.
So here you are having 1 to 1 as 1, 1 to 2 as 1, 1 to 3 as 1. So we are having a connection from 1 to 1 itself. So that is, we are going to keep it as 1. Right. So what, wherever you are keeping the values, those things we are having it as, we are having the connections. That's why we are keeping the values, right? So there we are going to keep it as 1 1 1. Okay. So for the second one, what is the connection matrix?
1 is to 2. 1 is to 1 0. 1 is to 2 2. 1 is to 3 1. 3 is to 4 1.
1 is to 2. What is the count?
1 is to
1
2
to 2.
2. 2 2 2.
1 to 2. No, if it connection is there, you have to give it as 1.
Okay,
Even though
okay.
it is having multiple connections or n number of connections, that doesn't matter. If
Okay,
connection
okay.
is there, you have to give it as 1. No connection, you have to give it.
Okay.
Okay. So for second one, that is 1 1 1. That is the case, right? So here we are having use of connection matrix in finding cyclomatic complexity numbers. So here we are having set of rules, that is set of steps that we need to follow. So for each row, count the number of ones and write it in the front of the row, right? So if you are having uh, three numbers, so we have to write those three numbers in front of the row, right? So then subtract from that count, ignore the blank rows if any. So in the first row for the 5.6 diagram, we are having three ones, that is three connections. So we are subtracting 3 minus 1, that is 2 we are getting. So for the second row, we are getting 1 minus 1, 0. And for third row, 1 minus 1, 0. So the cyclomatic number is equal to, so how many we are having? So add 1 to the sum calculated in step 3. That is, so add the final count of each row. Okay. So first you have to go for the count and you have to subtract 1 minus 1 from each row. Then first you have to write the number, then you have to subtract minus 1, then add the final count of each row, that is add the total count of values, then add 1 to the sum calculated in step 2, that is, so here we are having 2 plus 0 plus 0, that is 2 we are getting, plus 1 you have to add, then we are going to get it as 3. The final sum in step 4 is the cyclomatic number of the given graph. Okay, so you have to write the complete values of where we are having connections. So you have to go for minus 1 from the, that is you have to subtract 1 from the count. So if you are having any zeros that you need to neglect or negotiate, so then you have to go for adding all the three columns values, that is all three rows values or all four rows values, whatever we are available with. Then you have to add 1 to the some value, then that is going to be our cyclomatic number for the given graph. Okay, so for the second one we are having 2 minus 1, then 1 minus 1. So as we are having 1 plus 0 as 1, plus 1 number we are adding and we are giving it as the cyclomatic number. Okay, so that is the case with cyclomatic number. So we need to follow these steps, that is 5 steps we need to follow. Okay, so the next one we are having is use of graph matrix for finding set of all paths. So we have to use each and every path, that is each and every path we have to find, then only we could able to go for easily the connection matrix or the given matrix. Okay, so if we are not having any connections, we can simply ignore it as 0 or we can negotiate it with 0, right? So that is the case of the use of this graph matrix or use of graph matrix for finding the set of available paths or set of all paths. Okay, so here we are having one more example. Okay, so consider the graph matrix in example 5.6, that is the previous example itself, and find two link paths for each node. Two links paths. Okay, so two link paths in the sense, so we need to go for that given graph, and again the same graph we have to take and we have to go for the calculation. Okay, so for that we are having, in the first row we are having ABC, and in the second row we are having, and in the third row we are having E in the last column. So same values we are keeping in the first matrix and second matrix, and then we are multiplying these two matrix. So then the resultant is like this. Okay, A square comma AB comma AC comma BD plus C. So this is the solution, that is for finding the two link paths we should square the matrix, that is squaring the matrix yields new matrix having two link paths. Okay, so that is the example which is we are considering. So for this graph, so what they are asking is, so consider the given graph, derive the graph matrix. Again, we have to go for the graph matrix. Then we have to go for the squaring of that matrix. Okay, so from this figure, you can draw the graph matrix. So for that, you have to go for squaring of matrix. Okay, so can you do it? Is it okay for you to do the graph matrix. Yes.
Okay,
Graph
sir.
matrix in it. Okay. So
Yeah.
we have to check. We have to check with the connections. Then we have to go for the uh, squaring of that particular matrix, whatever we are getting. Okay. So that is there in that particular part. So then we are having loop testing, right? So where you have to go for testing the loops. Okay. So conditions will be there, and then you are going to go for the checking that particular conditions. So if it is going to be executed, what set of statements you are going to execute and how you are going to execute. So if it is not executed, then what set of statements you are going to execute. So here in loop testing, we are going to have simple loops, nested loops, that is loop within loops we will be having, and concatenated loops we will be having. So loop within loop and loops which are connected to each other we will be having, and unstructured loops also we are going to have in this particular loop testing. Okay. So simple loops will be there, loops within loops you will be having, and loops that are connected to one loop, that also you will be having in the loop testing. So that is the case of the loop testings. Okay. So then we will be seeing the data flow testing. So how we are going to go for data flow testing. So how the data is passing from one node to the other node, that we are going to check. That is said to be as our data flow testing. So whether it is reaching from node to node, or node to decision, then node to decision to node, or how it is reaching from source to destination, that we are going to check. So then we will be having that part testing, that is data flow testing. So how the data is going to be flown from one node to the other node, then we are going to go for the checking of all those things. Okay. So then state of a data object. So data objects will be either defined or killed or undefined, we are going to say, and then we are going to have it as usage. So state of a data object in the sense, so when we are going for this data flow testing, so you are going to create data objects. Okay. So if any data object is being created by you, or if it is already available, then we are going to say it as defined, and which is indicated with small letter D. So if you are going to use it, that is once the data is defined, that is once the object is defined, so then if you are going to use it in the data flow testing, then we are going to say it as released or killed, you can say. Okay. So that is, if it is not going to be used, then what we are going to do? So when the data is being reinitialized, or the scope of the loop control variable finishes, that is going to be set to as the release. Okay. That is going to be indicated with the help of K. And if you are going to use it, then you are going to say it as usage within the diagram. Then you are going to say it as usage. Okay. So first we are going to define the object, then we are going to use it, then we are going to kill it. Or else defining will be there with D, killing will be there, and then we are going to go for usage in some cases. Otherwise, the flow is from defining, usage, and killing. That is DUK. Okay. So data flow anomalies we are having, as we are having three different states, we will be having the combinations, that is define and use, define and kill, use and define, use and kill, kill and use, kill and define, define and define, use and use, kill and kill. So like that we are having anomalies, and we are having the explanations, and we are having the effect of those anomalies. Okay. So if you are going for define and use, that is allowed, that is the normal case, we can say. Okay. So then if you are going to go for define and kill, you are not using, so you are going to get errors, because you are not using it but you are killing it. Then if you are going to use and define, data is used and then redefined, that is also allowed. Okay. but it is also leading to some cases it is bugs. And usage and kill, that is also allowed as it is normal case. So killing and using, that is you are going to get severe cases of bugs, that is serious bugs you are going to get. And in case of killing and defining, um, data is killed and then the data is redefined, that is also allowed. So defining and defining, that is redefining, is also allowed, but bugs will be there which are harmless or harmful, that we need to check, right? So use and use, that you can use a number of times, that is also allowed in multiple ways, that is also normal form, right? So killing and killing, it is also not allowed, it is leading to the harmless bugs. Okay, so this is the data flow anomaly, we can say. So how we are defining, how we are using, how we are killing your data objects. Okay, so we are having three, and with those three we are having 9 different combinations. Okay, so those things you can easily find out in that particular data flow anomaly. Okay, so coming on to the next one, so anomalies will be there again. So with those anomalies we are having, so double anomalies we will be having. So what can be done and how you can go for the solution, that is also available in the next next PPT, that is in the next slide. You are having single character data flow anomalies, that is minus D indicates first definition, minus U indicates first use, minus K indicates first kill, D minus indicates define test, U minus indicates use test, K minus indicates kill test. Like that you are having anomalies. Okay, so is it clear? Data flow testing.
Yes, sir, it's clear.
So then we are having the terminologies that are associated with data flow testing. Okay, so that is terminology used in data flow testing. So we are going to use the definition node. So where we are defining, we are going to use usage node. So in usage node also we are going to have predicate usage node and computation usage node. Then we will be having loop free segment, that is loop free path segment we are going to say, that is which is not forming any loop. Then we will be having simple path segment, that is from reaching from source to destination or from one node to the other node. And then we will be having definition use path, that is TU path you will be having. So then you will be having definition clear path, that is DC path. Okay, so first you will be defining and then you will be clearing. In the other case you will be defining and using, and in simple path you will be having from one node to the other node, and in other case you will be having from loop free graph. Okay, so like that you will be having the terminologies which are associated with this particular data flow testing, use in data flow testing. Okay, so then we will be seeing this static data flow testing, so where no changes are going to be happening for the users. So if it is going to be a dynamic change, then it will be there. So here also you could able to check with the um, code which is having some organizations salary, HRA, DA, all these things are available. So this figure, that is that code is also given us what is there in that particular uh, line of code. So what we need to do, we need to understand the lines, then we need to go for the solution. So first let us check whether we could able to sort out it or not. So consider the program given below for calculating the gross salary of an employee in an organization. So it is related to calculating the salary of an employee within the organization. So if his basic salary is less than 1500, then HRA is equal to 10% of basic salary and DA is equal to 90% of basic. And if salary is either equal to or above 1500, then the HRA is 500 and DA is equal to 98% of the basic salary. Then calculate his gross salary. We are going to do that is calculation of the total salary of that particular person. We are going to test. Okay, so here we are having the starting of the program with main method. So basic salary, gross salary, DA, HRA is equal to initialize it to 0, and all these values are given to float. So which we could take decimal values also. That's why we have given it as float value. Then we are inserting the, that is then we are giving the salary. Then we are taking the salary, that is basic salary. So if the salary is less than 1500, then HRA is equal to basic salary into 10%, and DA is equal to basic salary into 90%. Otherwise, HRA is equal to 500, basic salary is equal to, DA is equal to basic salary into 98%, and gross salary is equal to base salary plus HRA. We are taking. Okay. So for the basic salary, what we are giving is, we are defining, using, and killing the patterns as given below. Okay, so first what we are doing in line 3, we are normal case of usage we are doing, that is defining we are doing. So in line 3 scanf basic salary we are taking. Okay, so then we are defining and using. Okay, 3 and 4 what we are doing, we are defining the basic salary and we are checking whether the basic salary is less than 1500 or not, right? So that is we are defining and using. So then again we are using 4 to 6, 6 to 7, 7 to 12, 12 to 14. We are using it, that is whatever we have defined we are using. 4 to 6, what is there in 4 to 6? Basic salary is there. So if basic salary is less than 1500, we are doing some calculation, that is HRA is equal to basic salary into 10% and DA is equal to basic salary into 90%, that we are doing. And 7 to 12 also we are doing, that is if condition we are executing and else condition also we are executing, and then we are going for the complete usage of that particular statements. That is also normal use, that is also allowed. So then you are going for 14 to 16, so which is given as gross salary, that is calculating of gross salary we are taking. So where it is having basic salary plus HRA plus DA. So and then you are printing the value, that is gross salary you are printing, and then you are closing the statements. So that is also available. Then you are going for the normal case of killing, that is after the usage is finished, then you are killing the values. Okay, so similarly we can go for gross salary, DA, and HRA. So these three tables represent our gross salary and HRA. So gross salary, DA, and HRA. So if you check, so in some cases you are having double definition. That is in HRA you are having double definition. That is first you are defining normal case, that is allowed. So when it is coming to 1 to 6 or 1 to 11, so double definition is happening. Okay, so 1 to 6 what you are doing, 1 to 6, so you are giving the values, then you are giving the basic values, HRA values again and again. So first you are giving it as 0, then you are taking the HRA value as some value, then you are again calculating the HRA value, that is again you are giving the HRA value as something else. That is double definition is there. So which is not allowed, but it is going to give us harmless bugs. Okay, so when you are executing those set of lines, so as according to the code it is available, then you are getting the perfect result, but which is not allowed in this particular testing phase. Okay, so that is the only difference between drawing these particular diagrams, that is drawing these particular tables. Okay, so four tables you are having, out of which 3 tables are in normal case and one table you are having double definition. So where you are having some problem, that is double definition is not allowed, but it is giving us the harmless effects, that is harmless bugs you are getting. Clear?
Yes, sir.
So then you are having dynamic data flow testing, that is you are having dynamic data flow testing, that is randomly you can change, that is dynamically you can change the values and you can go for the path testing. So which is one of the important aspect related to your exam point of view, that is path testing. When you are going to ask the path testing or data flow testing, okay, data flow testing, so you have to write the possibilities. So first case you are going to write all those 9, and in second case you are going to mention all these uh, methods you are going to get. Okay, so the first method you are going to get is all du path, that is all define usage path. So first you need to define, then you have to use, then all uses strategy, that is au. So whatever the states that you have defined, that you have to use, that is whatever the states are available, that you have to utilize at any cost. Then you will be having all user, all p uses and some c uses, that is uh, all predicate uses and some condition uses you are going to check, that is that you are going to check. Okay, so then you will be having all c uses, that is all conditional uses and some predicate uses you will be having. So this is also one of the strategy where you are going to go for defining your conditions, defining your predicates, then you are going to go for the solutions, that is you are going to utilize this. Then you are having all predicate uses, that is apu you are going to say. So predicates here indicates that your conditions only. Okay, so then your all computational use, that is acu you are going to say. So here all computational uses in the sense, so whatever you are computing, that you have to use. Okay, that is last one is all definition, that is all whatever you are going to define, that you have to use, or you have to define each and every statement or each and every line that you are going to use, that is each and every variable we are going to say. So like that we are having 7 different methods or strategies, right? So all these strategies are defined below. So what are all these strategies? Dynamic data flow testing strategies are 7 in number. So you will be asked a question of writing all these things. Okay, so for a simple diagram you can define all these things and you can go for the justification. Okay, so that is related to our data flow testing. So a quick check, check whether you are having mutation testing or not. According to your syllabus, mutation, okay, it
Yes,
might be
sir.
there.
It is there, sir.
Okay, let us finish this one also so that we can close this particular unit, we can say. Okay, so next one you are having is the mutation testing. So mutation testing is the process of mutating some segment of code, that is putting some error in the code. We are going to say that you keep some error in the code, then it is going to be having as mutation testing. Okay, so then testing the mutated code with the some test data. Okay, so you keep some errors and test the code, then you are going to say it as the mutated testing. Okay, so here you are having some code, so that is a greater than b, x is equal to x plus y, else x is equal to y, printf percentage d. Some code we are having and we are going to keep some error in that particular one, and we are going to give the solution again. So that is our mutation testing. Okay, so for mutation testing we are also having the process. Okay, so construct the mutants of the test program. So add test cases. If the output is incorrect, then again check for the output. So if the output is correct, then write the output. So if the output is mutant, differ from other things, what we need to do, like that we are having steps as well. Okay, so this is what we are having in the second unit. I think complete second unit is finished up to here, right? So is it the same? Second unit is done. So you're having black box testing and white box testing in unit 2, right?
Yes, sir.
So all these things we have covered. So I will check with the paper, that is the questions which are raised in this particular unit. So already we have seen the first unit and second and first part questions also. Second unit parts we will see right now. Or else again I will go with the second unit test, that is second unit questions. So what are all various types of errors detected by black box testing? Explain that you can write. So discuss basis path testing with a neat sketch. They are asking that you have to write. So explain about cause effect graph based testing and decision table based testing. That is also covered. Write applications of data flow testing. So applications you can go for all those methods, right? So those are the questions which are covered in unit 2. And in another set of question that you are having is, how do you represent graph matrices for testing process? Devise the same with example, that is devise the same with the example. Okay, that you need to write. So what you need to write, you have to go for what is graph matrix, how it is going to be useful, and all those things you have to mention. Explore on state table based testing and error guessing that we have discussed. Then explain in detail about black box testing techniques with examples and neat diagrams, that is neat sketches. That is also fine. Okay, so in one set we are covering one kind of questions, and the other set we are covering the other kind of questions. Okay, so if this one is clear, we can quickly move on to the next unit, that is unit 3, we can say.
Okay, sir.
Okay, we will once again I will share the screen, and then we will go back to the static testing, I think. Testing techniques we are seeing, where in white box testing, black box testing we have covered. So then we will check with the static testing. Okay, so could you able to see the screen again?
No, sir.
Just
Not visible. Yes, sir. It's sir.
okay, now you could able to see the
Sir.
screen, I think.
Yes,
Right,
sir.
so in the static testing, that is in third unit, what we are going to see, just we will overlook, that is we will have a look into these concepts, and then we will move on to the unit 3. So in this particular unit, or after reading this particular chapter or unit, we will be able to understand static testing. That is, static testing is complementary to dynamic testing. Static testing also improves the software quality. Then some bugs can be detected only through static testing. 3 types of static testings, that are inspection, walkthroughs, and reviews. Then inspections are not most widely used technique for static testing, which is formal process of detecting the bugs early. Benefits and effectiveness of inspection process. Then variants of inspection process. Then walkthrough is less formal and less rigorous method as compared to inspection process. So review is higher level technique as compared to inspection or walkthrough, as it also includes management representation. That is management representatives. Okay, so after going through this particular portion, we could able to differentiate what is the difference between a walkthrough, what is the difference between a review, and what is the difference between a inspection. Okay, so what is inspection, what is review, and what is walkthrough, and out of these three, which one is the best approach or best practice that we are going to see, or that we are going to uh, adopt, that we will be coming to know after reading this particular unit. Okay, so here we are having types of statics testing as three. Okay, so here what about this static testing is, so in statics testing we are going to test the complete code or the parts, we will be going for testing the complete code. So we are having three different types of testings. So one is software inspections, the other one is walkthroughs, the other one is technical reviews or reviews we can say. So coming to the first one, that is inspections, we are going to have the inspection team. That is inspection in the sense we are going to check with the coding part or the development part, everything we are going to check. So we are going to inspect, so where we are going to go for set of rules, that is steps we are going to check, and role for the participants we are going to check, and then item being item. So for this we are going to have the inspection team, that is who are the people, uh, the persons who are going to test or who are going to inspect that particular code we will be having, that is set of people we will be having. Okay, so where we are having author or owner or producer of the particular product will be available, then inspector is going to be available, right? So moderator will be available, that is a team member we can say, and recorder will be available, who is going to record all the results will be available in this particular inspection team. Okay, so in inspection team we are going to have the author or owner or inspector who is going to test, moderator a team member, and recorder who is going to record all the mm, process, that is results and all the process who is going to record, that person will be there. So for this inspection we are having a set of steps that we need to take. Okay, so first we will be having planning, then we will be having overview, then we will be having individual preparation, then we will be having inspection meeting, then we will be having rework, then we will be having follow up. Okay, so likewise we are having six different steps or six ways to go for the inspection process, that is six steps we will be following for inspecting the particular process. Okay, so in planning what we will be doing, we will be planning for the inspection meeting, that is so on so and so date we will be having the inspection on this particular project, that we will be planning. So after planning, then we will be defining the purpose of the inspection meeting, that is what is the purpose of conducting that particular meeting, why we are conducting that particular meeting, what is the intention, and all those things we will be discussing, that is we will be defining before we go for inspecting that particular meeting, or before we go for that particular meeting. So then we will be going for individual preparation, that is team members identify the potential errors. So individual persons will be identifying the errors that are available in that particular code, and then they will be going for that particular inspections, that is where we are lagging, what we are lagging, and how we can improve, all those things we will be discussed in that particular individual preparation. As a individual, what are the drawbacks of that particular code, whatever you have written, and how you can overcome all those things, that we will be discussing in the uh, next level, that is individual preparation. and then you will be going for inspection meeting, right? So in the meeting we will be discussing about all the aspects that are related to that particular product. Okay, so then item is inspected in the inspection meeting. So in inspection meeting, everything will be discussed, and after discussion, it will be going for, if we are having any errors or any bugs in the code or any errors in that particular project, then the reworking is going to be done. That is, bugs are going to be uh, overcome. That is, bugs are going to be reported and they are going to be sorted out. That is, bugs are going to be removed, and then again you are going for the follow up. Okay, so after rework also, that is, once the bugs are also covered and the program is that is, the module is going to be deployed, then again you are going to go for the follow up. That is, planning and overview of that particular project or that particular document, we can say, or that particular task which is being assigned by the developer or the customer to the management. That is a team or group of people who are working for that particular project or product. Okay, so inspection process is going to have the similar kind of process what you are doing in the life cycle phase, but here the roles are going to be changed. That is, planning, you should have the separate planning for what you are going to inspect, and how you are going to define all those things, how you are going to execute, how you are doing if you are getting errors, how you are making the team to rework. All those things you need to check, and you have to follow up the each and every activity. Okay, so here the terminology is going to be different, but the process what you are doing is going to be similar kind of process that what we are doing in the what we can say life cycle model, sorry, life cycle phases. Okay, so that is again discussed over here. That is planning, overview, individual preparation, right? So inspection meeting, rework, follow up, right? So all these things are there. Okay, so then what are the benefits of this inspection process, right? So if you are going for this inspection process, so what are the benefits that we are going to get is our next question. Okay, so once you are going for this inspection, so you will be coming to know the errors in advance, right? So those bugs reduction will be there, bug prevention will be there, productivity will be more, and real-time feedback to the software engineers will be great, and reduction in development resources will be high. Quality improvement will also be there for the users, that is for the development, and project management will be there as you are checking in advance in the inspection review itself, and then checking coupling and cohesion will be there. That is, wherever you are getting errors and how to overcome all those things, you will be coming to know in the advanced level itself. Then you will be having learning through inspections. That is, you will be coming to know what are the drawbacks of your uh, team and as an individual, and how you can overcome all those things. That is, how you can cover up with uh, bugs, and how you can develop yourself, that is, improve yourself. Then you can check with the process improvement, and then you can go for finding the most error prone modules. That is, what are the modules that you are getting mostly the errors in the product or project, you will be coming to know. Then you can go for the uh, distribution of error-free bugs, and all those things can be done with the help of this particular inspection process. Okay, so these are the various benefits that you are going to get or gain when you are going for the inspection process. That is the process which we are adopting over here in the previous phase, we can say. That is the inspection process. Clear?
Yes, sir.
So are we moving bit fast or slowly?
Slowly, sir.
Okay. So then coming to the effectiveness of inspection process. So what is the effectiveness? We are going to go for the error free, and when you are going for the inspection process, you will be coming to know what are missing and what is to be added into the project, so that by default or by chance we could able to go for the reduction of cost, right? So we could able to go for the various variants of inspection process. That is, if you are having any other various things that we can go for changes, all these things we can go and do it as an inspection process. Okay, so then active design reviews, that is that we can check with the active reviews. That is, we can go for checking, reviewing, and all those things we can do. And formal technical approaches or asynchronous reviews we can check with one step after other. That is, setup we have to keep orientation, private review, public review, then cancellation, that is consolidation, group meeting, then conclusion. So this method you can approach, or you can go for the previous one what we are having in the inspection reviews, right? So synchronous method you can adopt, or Gilby inspection process you can adopt. That is, you are having planning, kickoff, checking, logging, brainstorming, edit, and follow up. So this process you can adopt, or that process you can adopt, or you can also go for M-phrase inspection process, which is again having planning, overview, preparation, analysis, inspection, rework, and follow up. Okay, these are the process we are having. So we are also having n-fold inspection, where you will be having n number of foldings, so you can say. That is, you will be having the phases as usual, and you will be doing it in n number of ways. Okay, that is n number of phases we can say. Okay, then you will be having phased inspection, that is single phase, and multi-phase inspection that you will be having as a whole for testing that particular coding part. Okay, so then you will be having the reading techniques, so where you are having ad hoc methods and checklists, and scenario based mod, that is reading, right? So in scenario based reading you are having again perspective based reading and usage based reading. That is, whenever it is necessary that you are reading, and whenever you are using that you are reading. And abstract driven reading, you by taking the reference of your abstract, you will be reading those things. And task driven reading, that is task related aspects only you will be reading, and you will be going for the solutions. Then you will be having the function point based review, that is function point based scenarios, where you will be having functional point, where you are having the functionalities, that points you are going to cover, and you are going to go for the solutions. Okay, so then we will be checking with the checklist, that is whether we have missed anything, or we are completely covering the entire things, that we will be checking with the help of all these inspection processes. Okay, so this one is clear, that is inspection process.
Yes, sir.
సార్
Yeah,
సార్ అవుట్ సిలబస్ ఉన్నవి వదిలేస్తే సార్ అవి కూడా చూసుకోవాలా సార్?
ఏమైందమ్మా?
సిలబస్ లో లేని టాపిక్స్ వదిలేచ్చేసారు, లేదంటే అవి కూడా ఒకసారి చూసుకోవాలా సార్?
మీకు సిలబస్ లో లేని టాపిక్స్ మనం ఏం మాట్లాడట్లేదు. ఆల్మోస్ట్ ఎవ్రీ టాపిక్ ఇస్ దేర్ ఇన్ యువర్ సిలబస్. మీకు ఉన్న టెక్స్ట్ బుక్ లో మీకున్న సిలబస్ లోంచి చూసుకోండి ఫస్ట్. సో వాట్ ఎవర్ ది సిలబస్ దట్ యు ఆర్ హ్యావింగ్, నో, దట్ వి నీడ్ టు చెక్ ఫస్ట్. జస్ట్ వెయిట్. సో ఐ యామ్ గెట్టింగ్ డౌట్ వెదర్ ఐ యామ్
ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూ లో అవుట్ ఆఫ్ సిలబస్ వదిలేయచ్చా సార్, లేదంటే అవి కూడా ఒకసారి టచ్ చేయాలని అడుగుతున్నాను.
Exam point of view లో you can leave the out of syllabus, no issue.
ఓకే సార్, ఓకే సార్.
Okay. So in static testing, we are having all these things: inspection, structural walkthroughs, technical reviews, all these things we are having. Regression testing we are having. So in exam point of view, they will be asking you the questions related to your topics only. That is what is there in your syllabus, that only they will be asking. Okay.
ఓకే సార్.
So those things only they will be posing the questions, but in tricky way or directly they will be asking.
ఓకే సార్.
Then the question is then the topic is structured walkthroughs. Okay, so here walkthroughs are simply nothing but you are going to test your complete model or the complete project, right? So it can be done with the help of user, it can be done with the help of tester. So in multiple points of view, so where you will be having coordinators, project developer, that is presenter or developer, scribe or recorder, reviewer or tester, maintenance oracle, standards bearer, user representatives. Like that, you will be having the structured walkthroughs. Okay. So walkthroughs in the sense you are going to go for typical walkthroughs can consist of the following members. So walkthroughs are simply nothing but we are going to go for testing. Okay. So the common term used for static testing is inspection, but it is very formal process. Okay. So the next one is technical reviews. So technical reviews indicates or is going to test with the technicalities of that particular project. Okay, so technical reviews are we are going to go for the technicalities, what are the competency level, what are the completeness of the project, what is the completeness of the project, what is the documentation is available, how the documentation is done, and whether we are using appropriate problem definition or not, whether we are having adequacy assumptions, whether we are having the that is whether we are going with the standards or not. Those things we will be checking in the technical reviews. Okay, so in these three topics, inspection process, it is having much weightage. So once we are clear, then you can go for these two remaining topics. Okay, so then validation activities do we have in the syllabus? Just quick confirmation from your end. Validation activities.
No sir.
Sir, yes, sir, yes, sir. It's there. I think it's third.
Yes sir, second
Validation
topic.
validation activities is second topic. Okay,
Okay, sorry.
that is included in the syllabus.
Yeah, it's there.
Just wait, again we will go for that particular topic. We have not skipped it, we are coming one by one. So validation activities are simply we can say it as they are going to validate whether the project is okay or not, or what are the kinds of things we can check and we can validate whether it is related to the project or not. We are going to test in this particular validation activities. Okay, so here we are going to, after reading this, we are going to get validation is the next step after verification. That is, you need to verify the things before you are going to validate any project or any product that you need to check. That is, after verification only you will be coming to know the validation. Then validation is performed largely by black box testing techniques. So validation is mostly done with the help of black box testing that we could able to understand after reading this particular unit. And then unit validation testing and role of stubs and drivers in unit validation. That is, what are the various roles that are available in unit testing that we are we could able to know after reading this particular unit. Then what about integration testing, and what are the other aspects that are related to the integration testing? We will be coming to know after reading this particular chapter or unit, we can say. So where we will be seeing what is call based, that is what is call graph based integration, path graph based integration testing, that we will be coming to know. Then we could able to go for the types of decomposition based integration, that is top down integration and bottom up integration, we will be coming to know. Then you will be coming to know about the function testing. Then we will be saying we will be coming to know the system testing and its types, like recovery testing, security testing, stress testing, performance testing, usability testing, and compatibility testing. Then we will be coming to know the acceptance testing and its types, and alpha and beta testings, when we will be completing the reading of this particular validation activities. Okay. So while coming to the validation activities, we will be having set of activities where we need to check with the validation. Okay, where we need to check with the validation. So this is V and V activities which we have seen in our previous class, that is verification and validation, where you are having unit testing, functional system testing, acceptance testing, and installation testing, that we have seen in the V models, or V and V model, we can say. In V model we have seen, that is in V testing we have seen all these activities: verification and validation, how the verification is being done and how the validation is being done, that we have seen in the previous class. So that diagram is useful for us in this particular validation activities. Okay, because we need to go for first process we need to do is verification. After verification only we could able to go for validation. Okay, so in the validation process we are having first as unit validation testing. So where you are going to have the drivers. Okay, the terminology is drivers you are going to use, right? So where you will be having a number of modules, those modules you are going to give it as the hierarchy. So which module has to be tested first, which module has to be tested next, like that you will be having, right? So there you will be keeping some drivers, that is which module is going to be taking that particular module forward, that you are going to give. So for that you are going to say it as the driver module of that particular thing. So coming to the stubs, so dummy modules are called as stubs. Original modules, or whatever the modules that are available for us, are called as our drivers, which are uh, capable of doing, or which are doing the testing process, we can say, that is taking us to the end or taking us to the last. Okay, so here in this case you are having stubs as module D is having stub, and module E is also having sub module, that is sub module E is having, sub module D is having, and sub module E we are having. These are all the stubs, that is dummies, we can say, right? So then comes how why we are going for this stubs and this so-called drivers. So drivers and stubs are useful for us to get the benefit, or to get the solution of what we are testing and how we are testing, how the testing is moved forward, right? So whenever we are moving furtherly, we will be keeping some uh, dummies you are going to keep, and you are going to go for the testings. Okay, so then we are having the integration testing, that is merging of more than one modules into module into the other modules. or submodules you are going to merge and make it as a huge module, which is called as the integration process. So for that, you are also going to go for the testing. Okay, so here you are going to have the incremental based testing and non-incremental integration testing. So that is, in step by step, you can go for integrating, or as a randomness also you can go for implementation. That is, integration you can do one by one, or you can do randomly. Okay. So here you are having a bottom up integration and top to bottom integration. So in top to bottom integration, we will be starting from the top level, and then we will be moving forward, and we will be going for the solution. We'll be giving for the solution, and in bottom up, we will be starting from the bottom level, and we will be moving forward to the top level. Testing. So, but they are going to have the different architectural style, system demonstration and test implementations. They will be having in the different manners. Okay, so as it is theory one, you can go for the readings. No issue with that one. Path-based testing and all those things we have covered in the previous classes itself. Then we are having function testing. Then we are having function testing. So that system testing we are having and function testing we are having. So function testing is going to deal with the functionalities and its testing, and system testing is we are going to have the complete testing of the system, starting from the starting node till the last node. Okay, so these are the kinds of testings we are having. Then acceptance testing that we will be doing. Okay, this acceptance testing, alpha beta testing, we can cover in tomorrow's class, and we can close that particular second part, and then we can go for the regression testing. Okay, or else we can shall we proceed with this testing? Shall we proceed with the acceptance testing, or shall we look into it in the tomorrow's class?
Sir, we can look into it tomorrow class, as we have only class. So tomorrow, if we start freshly, means we can expect more participants also. So it is better that we can.
Okay, so we can continue in tomorrow's class that acceptance testing.
Okay,
sir.
okay.
Okay.
Yeah.
Okay, okay.
Thank you, sir.
Okay, fine. Okay, fine.
Sir, can you send the PDF?
I have already shared, no? Rajesh sir also I already shared in your group, I think.
Okay, okay. I need to check that. Okay, I will check.
Okay.
Okay, okay, sure.
Okay, fine. Okay, anyone can leave the class and join in tomorrow's class. Okay,
Okay,
Okay.
sir. Thank you, sir.
everyone can leave. Leave and join in tomorrow.
Okay, sir, sure. Okay, friends, you can leave this class. So please leave.